Good morning, boys and girls, and welcome to math class. So today we are going to be looking at 12.9, and we are going to be looking at relating shapes, fractions, and area. Now, one of the things we need to talk about is area, because we skipped over perimeter and area. We're going to be going back to that. We have talked a little bit about area when we were doing multiplication. So when you think of perimeter, you think of wallpaper. It's the outside edge. Whereas when you think of area, I think we talked about this. We said area is like an area rug. It's the area that's covered by an area rug. So you think of the inside of a room, like the flooring. So whenever we get to that part, I just wanted you to know that we'll discuss it in this chapter, but we're really going to get into detail when we go back to chapter 11. We'll finish 10 and then we'll get into it in chapter 11. All right, so back to geometry. So it says relate shapes, fractions, and area. We are great with fractions. We know fractions have a numerator and a denominator, and we know the numerator is on top, and that's what they're talking about, the amount they're talking about, and the denominator is how many is in the whole. So when the fraction part comes up, just a little reminder about numerators and denominators. So the essential question is right up here, and it says, how can you divide shapes into parts with equal area? So there's equal, and then areas like the flooring, it's the inside of a shape that we're talking about. And write the area as a unit fraction of the whole. So we know fractions, we have numerators, which talks about how many parts you're talking about. And then you have the denominator, which is how many are in the whole. So we're just going to review all of this as we go. All right, so we're going to investigate. First thing, we have our pattern blocks, colored pencils, and a ruler. We are not in class, so we do not have our pattern blocks in front of us, but I did make a hexagon right over here, and I'm going to try to demonstrate this on the computer. Bear with me because you know technology is a little iffy. We're all kind of duct taping our technology together, and some days it works and some days it doesn't. So just bear with me. So it says connect. You can use what you know about combining and separating plane shapes. Think about what a plane shape is to explore the relationships between fractions and area. Fractions, a numerator and a denominator. Then you have the area, which is everything inside, okay? So it says, trace a hexagon pattern block. I traced it right over here on the right. B says, divide your hexagon into two parts with equal area. So that means I'm going to divide this into two equal parts. So that's not hard to do. So let's get our line and we'll divide it and we'll use red so you can really see it. So for me, I see right away that I can just cut it right in half. Okay, I'm going to go from edge to edge, the outside. So you can see I divided my hexagon into two parts with an equal area. So if I go over here, I can see right here, this is one part and this is two parts. So I have two parts. So it's into two equal areas. Area is the inside and we see this is the same as this. It says write the name of the new shapes. So what is this shape? Okay, well, let's real quick here. Let's go through and let's count our sides. So we've got 1, 2, 3, 4. Now I'm not using those to show equivalent sides. I know they were talking about equal ticks, and I'm not using these as equivalent ticks. I'm just using them to count the sides, okay? These sides are not all equal. So it has 4 sides, and then if I counted the bottom, I would do 1 again, 2, 3, 4. So they both have 4 sides. Okay, well, let's say I want to decide what shape it is by extending out the top here. So if I extend this out, this line segment, and I extend this line segment, I can see that this line and this line are parallel to each other, but when I extend these up, they are not parallel, they intersect. So that makes this shape a trapezoid. And if I did the exact same thing here, and I took and extended out these line segments, I could see that these line segments intersect, whereas this one and this one are parallel to each other, and that is a trapezoid. So we have created trapezoids right here, and we also have quadrilaterals. All right, let's see here. Let's go to, then it says we divided it in half. Here was 1/2, 2 halves. So we could write, I'm not sure if I'm able to write a fraction here. So like if I did 1/2, so 1/2 would go right there. Make it small so you guys can see. All right, so there's our 1/2. We divided it in half. Each part is 1/2 of the whole shape's area. So remember, area is everything inside, which we're going to learn a lot about in chapter 11. So don't get discouraged if you're not thinking about area and what it means yet. You will, don't worry. And then it says, write the fraction that names the whole area. So if I talk about 1/2 here and 1/2 here, then that would be 2 halves. So that would be 2 halves, which is equal to 1 whole. Okay, and I think you guys remember that because we've done a lot with fractions. So 2 halves is equivalent to 1 whole. All right, so we're going to go down below and it says draw conclusions. So it says explain how you know the two shapes have the same area. Okay, well, let's look. Here is our 1, 2, 3, 4, 5, 6. There's our hexagon. And it says, explain how you know the two shapes that you created have the same area. Well, if I take my shape here and I add a trapezoid there, and I add this exact same size trapezoid. So if I took this and I twirled it around, woo, and I slid it directly on top, if I can do that. It's not letting me. There you go. You can see that they're exactly the same. So I just made one there. Take this guy and twirl him around. And move him right there. You can see they're the same area inside. So you could say I can cover the area with the two trapezoids. I made two trapezoids and I covered them and I put them over top of the hexagon. They are the same shape and the same size. Number 2, predict what would happen if you divide the hexagon into 3 shapes with equal area. Okay, well, what fraction names the area of each part of the hexagon? So if we divide it into 3 parts, okay, so you'd have to come up with a way to divide this into 3 equal parts. That means that you would have 1/3. So you would have 1/3 if you divided it into 3 equal parts. And if you have all 3, you would have 3/3, which is the whole, which equals 1 whole. Okay? Show how you can divide the hexagon into 4 shapes with equal area. So you could do that. Hopefully you're doing this as I'm doing it. You could take it, and if we divided it right here and right here, you should get, so right there's half, correct? Would you agree with that? And then if you went here and you went across, you should be able to see that this area is the same as this area, which is the same as this area, which is the same as this area. So you have 4 equal parts. So it says each part is what? What would the fraction be? Well, hopefully if you look, you have 1, 2, 3, 4. So if you only look at one part, let's see if I can do this. Let's do a highlighter. If we just highlight this part right here, you can see that that is equivalent to 1/4. So you have 1/4 of the whole area's, the shape's area. So there's 1/4, 2/4, 3/4, 4/4. You have 4/4, but the one part that we're talking about is only 1/4. All right, so we're going to move on to the next page. Please make sure you're following along. These concepts build on each other, so we want to make sure that each day we're going through this workbook together. All right, so making connections. The rectangle, and you can see the rectangle right here on the right, is divided into 4 equal parts. So there's 1 part, 2 parts, 3 parts, and 4 parts. I hope you can see that. It says write the unit fraction that names each part of the divided whole. Okay, well, here's the whole, and it says write a fraction that names each part. So this would be 1 part, so that would be 1/4. This would be 1/4. This would be 1/4, and this would be 1/4. So hopefully you are writing 1/4 for each part. And it says, what is the area of each part? So we want to go to 1 part, and remember the area is the inside. So it was like if you put a rug down, an area rug. So then you count the inside parts. There's 1, 2, 3, 4, 5. So there are 5 in each part. So let's just check the second one. 1, and okay, let me make sure that you guys are seeing me. My pen. So there's 1, 2, 3, 4, 5. So that would cover all of it. So there's 5 in that one. Let's keep going. 1, 2, 3, 4, 5. So there's 5 in every single one. So your answer would be, for right here, would be 5. Okay? So it says, how many 1/4 parts does it take to make 1 whole? Well, you want to look at, here's your whole. We have it broken up into 1, 2, 3, 4 parts, so it would take all 4 parts to make a whole. So hopefully you wrote 4. So this next one, it says, is the shape of each of the 1/4 parts the same? Well, absolutely. You can see that they are not all the same. So if you look, is the shape of each 1/4 the same? It doesn't say same amount of space, it says the shape. So absolutely not. This looks like an L. I don't know what these ones look like. Okay, but you can tell that they're arranged differently. So that would be an absolute no. Now, if it says same size, the area, yes, they are 5, but it says the same, it says shape. So the shape is the key word there. And then it says, is the area each of the 1/4 parts the same? And so that is That is yes, because if you look here, you can see, you count the unit squares, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yes, there are 5 unit squares for each 1/4 part. So the area of each is 1/4. So they are the same area. All right, so we're going to move down. And it says divide the shape into equal parts. All right, so hopefully you are able to see, just like we did before, that you can take these and make them into different shapes and actually divide them equally. So first of all, think about how you can equally divide something. First off, you want to know how many's in the whole. So maybe that might help. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 8 times 3 is 24. So let's just mark that down. So we've got 8 times 3, if I can get my thing to work, we've got 8, and we're going to do times 3 equals 24. Okay, well, how could we do it? Is there another thing that equals 24 that we could do? Maybe 6 times 4 equals 24. That could work. Okay. So we could take and we could divide it into 4s. We could just do 4. I was trying to make it equal to 24, but maybe I can see right here, there's 6, there's 6, there's 6, and there's 6. There's 8, there's 8, there's 8. Draw lines to divide the rectangle below into 6 parts with equal area. So that's why I was trying to get the 6, because we can see right here that we have to, and it says right here, we had to divide it into 6 parts. All right, so we did some multiplication. We saw 8 across times 3 gave us 24. We know we had to divide it into 6 parts, and we know that 6 times 4 is 24. So that's really going to help us out. Let me get back to my pen, and we'll get back to drawing some lines. All right, so let's do some really thin lines here, and we can go down like, let's go down, just I'll start with you right here. There's 1, 2, 3, and 4, because we need 4 in each group. So maybe if you go across, and then if we go down. Okay, so there's one group. Okay, so if we maybe could go across right there. Kind of messed that up. Not really to go up here. And then across. And then up. So there's that same shape. It's like a, kind of like a boot. There's a boot. There's a boot. There's 4 and 4. And then if I go down, look at that. I've got 4. 1, 2, 3, 4. 1, 2, 3. I've got 3. I know I have to have 6. So I could do my boot again. So I could go up. I could go over. And I could go up if it would let me. Oops. And then I could make my box here. Boy, is this messy. So there's my 1, 2, 3, 4, and there's my 1, 2, 3, 4. And then go here. I have my 1, 2, 3, 4, 5, 6. Hopefully yours looks so much better than mine because mine's a mess. So you can see, write the fraction that names each part of the divided rectangle there. My whole is a rectangle. I divided it into 6 equal parts. So every part would be 1/6. So that would be the fraction that names each part that I divided it into. There's 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So each part is 1/6. Write the area of each part. Remember, the area is the inside of each part. So that covers, hopefully you're seeing that it covers 4 unit squares. So that's how much it covers. So each part is 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So each part is 1/6 of the whole. Okay. All right, so we're going to pause. Actually, I'm going to do the share and show at the end because a lot of times the computer just totally freezes after I do the share and show. So I will put the share and show at the end so I don't lose you. All right, so going down below, oh, this one's really cool. This is awesome. So let's read this. It says, divide the trapezoid into 3 parts with equal area. The area is the same inside. So that means however much space that you have in one part, you have to have in all parts. So 3 parts with equal area. Write the names of the new shapes. So I'm going to give you a second to think about how can you divide this trapezoid into 3 equal parts. Go ahead. All right, hopefully you came up with 1, 2. And if you look, you now have 3 parts that are the same. So if you look here, this is equivalent to this, which is equivalent to this. So you can see all 3 parts are equivalent, which means they have equal area. This inside is the same inside as all the others. So you have 3 triangles and they are each equal to 1/3. All right, so we are on to the next, and we are draw lines to divide the shapes into equal parts. So hopefully you have your pencil and you are ready to go. It wants us to divide this into 1/6. So we have to divide it into 6 equal parts. So find the centers always. So that right there is really easy. So then go corner to corner. So there's one corner to corner. And then if you went here, you would go straight across. And then you would draw that straight across. And you can see that you have broken that into 6 equal parts because we know fractions are equal parts. So this 1/6 is equal to this 1/6, which is equal to this 1/6, which is equal to this 1/6. Over here, it says draw this into equal halves. So hopefully you can see if you folded this diamond in half, you would see this triangle, if I flipped it over, was right on top of this triangle. Now this one's a little tricky. This is a rectangle, not a square, so you got to be careful with rectangles. You cannot go from here to here. They're not going to be like if you did it from here to here and then here to here and then down, it would be tricky to get your 1/8, all of your eighths equivalent. So it'd be really simple if you just took it, you cut that in half, and then you cut that in half. Because remember, 4 times 2 is 8. And you wanted to break it into equal eighths. So 1, 2, 3, 4, 5, 6, 7, 8. You broke it in half first. So you had 2, and then 2 times 4 is 8. So that would give you your 8 equal parts. Multiplication is going to help you with division. All right, so make sure you're practicing your multiplication and division facts because they're not going to go away. So it says draw lines to divide the shapes into parts that have equal area. Write the area of each part as a unit fraction. Remember, area is the inside. So I'm going to show you something really simple to do. So you definitely want to break these into equal parts. So you always start with the halves if you can. And we know 8 divided by 4 would give you 2 in each group. And we just did that up above. So hopefully you breaking this into 4 equal parts, just like we multiplied 2 times 4 and it gave us 8. We took the 8 and we divided it in half and got your 4. This one says 6 equal parts. This one is like the L's again. So you want to go up, you want to go over. I know this is hard for me to do, so hopefully you're doing it because you guys have a little more room to work. Okay, and hopefully you're seeing that you had 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24, but we know we are doing it into 6 equal parts, so 24. So then you do, remember, multiplication and division, so then you do 24 and you divide it. I don't know if I have a division sign on here, but just pretend like my subtraction sign is a division sign because I don't see my division sign. Divided by, oops, I'll put some dots in a second, divided by 6 because they're saying 6 equal parts is going to equal 4. So you're going to divide it into 6 equal groups, which means each group is going to have 4 in each group. 1, 2, 3, 4. So that's up to you. Next, you have this one here. So we want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divided into 4 equal parts. Hopefully you know that you have 12 whole in the group divided by 4, because it tells you 4 equal parts is going to equal how many in each group, everybody? Hopefully you're seeing that 12 divided by 4 is going to equal 3 in each group. So you're going to divide that, get 4 equal parts, and in each one there's going to be 3. Multiplication and division will help you. Okay, your problem solving. Going down below, it says if the area of 3 diamonds is equal to the area of 1, it looks like 1, 2, 3, 4, 5, a hexagon. The area of how many diamonds equals 4 hexagons? So you want to go here, 2 equal parts. So we know how to divide a hexagon in half. 2 equal parts means halves. So that would be 1/2. Divide each shape into the number of equal parts. Then write the fraction that describes each part. There's 1/2, 2 halves. So you'd write 1/2 here. Down below, 4 equal parts. So you want to divide this into 4 equal parts. So you are going to go from, I'm going to go from here, oops, I need my lines. We're going to go from here to here. There's 1 equal, those are equivalent. And then we're going to go from here to here. So those should be equivalent. So 1, 2, 3, 4. So each part is 1/4. This says 6 equal parts. So I'm just going to divide it in half first off. And then 6 equal parts. So I've got it in half. So now 2 times 3, 1, 2, 3. So 3 times 2. Remember, multiplication and division is going to be your best friend. All right, so sense or no sense. So it says divide the hexagon into 6 equal parts. So you're going to divide this into 6 equal parts. So you're going to go, hopefully you're doing this. Hopefully you can see yours. 2, 3. And then it says which pattern block represents 1/6 of the whole area. So 1/6, here's 1/6, and that would be the shape of a triangle. Go over here, divide the trapezoid into 3. This one's a cool one. We did this earlier. And it says which pattern block represents 1/3. That is also a triangle, which is really neat. And you can see that this is over here. Okay, so it has 2. If you put that one over here, you'd have 2 trapezoids over here. Uh-oh, Judith is getting excited. All right, so then we have Alexis said the area of 1/3 of a trapezoid is greater than the area of 1/6 of a hexagon because 1/3 is greater than 1/6. Does her statement make sense? So if you look at the fractional parts up above, you can see that 1/3, okay, Alexis says the area of 1/3 of a trapezoid is greater than the area of 1/6 of a hexagon. So if you look right here, here's the trapezoid and here's the hexagon. Can you see them right here? And I said if you move this over, you would have to have 2. So does her statement make sense? No, it does not, because all the triangle parts have the same area, but since the holes are not the same size, they cannot compare them. So this would be 1/3, 2/3, 3/3, but if you moved it over here, there's 1/3, 2/3, 3/3. But since we have 2 of those, these are 6. So you can see that that does not make sense. So it says write a statement that does make sense. Well, the area of 1/3 of the trapezoid is equal to the area of 1/6 because we saw that we could just stack them right on top of each other. And then what if you divide the hexagon into 3 equal parts? Write a sentence that compares the area of each part of the hexagon to each part of the trapezoid. So you could say, and I'm just going to move this up to answer it, that the area of 1/3 of the hexagon is greater than the area of 1/3 of the trapezoid. All right, so you're going to go on to your lesson check. I'm going to give you a moment to go through and do your practice and your homework and your lesson check. So pause the video, do this, and come right back. All right, so you can see draw lines to divide the shapes into equal parts. We've done this multiple times, so hopefully you were able to use division and multiplication to get your answer. And you should have been dividing these along the lines here so that you could see 1/8 here, 1/8 here. This, you could divide this right in half here. This one, 4 equal parts. Hopefully you drew like little lines like this. So you had 4 equal parts. This one, 6 equal parts would be something like this. So you would have 1, 2, 3, 4, 5, 6. And then this one over here, just 3 equal parts. Hopefully you were able to come up with something like that. And then you were to write down like 1/4, 1/6, 1/3. Problem solving. Robert divided the hexagon into 3 equal parts. Hopefully you divided into 3 equal parts, which was really cool because it turned into a cube, which was pretty neat. So you got it right here, and this was so awesome. It's a 3D shape now. It takes on, looks like it takes up space now, and it was 1/3. All right, this one, you were to trace a pattern block. We're going to move past that one if you had trouble. The lesson check, Name the part that's shaded. 1/3. You have 8/8, which is shaded. That names all of it. Lil drew the figure to below. Is it open or closed? It's closed. This is 5 line segments to create a pentagon. The Venn diagram, where the 2 circles overlap, would be the place where the square would be placed. And then where would a rectangle be placed? And it would be placed in the circle labeled polygon with right angle right here. All right. Well, that was a very detailed lesson. I hope you enjoyed it. Tomorrow we are going to get started on our review for your Chapter 12 test. So make sure you really follow along, pay attention to all the little details that will help you with your quiz that I'll be giving you after Wednesday's lesson once we do 2 more days of review. Have a wonderful Monday. Take care, and I miss you all.